Welcome, and thank you for joining me this fine afternoon. I am Vinay, and I'll be your partner for the next 45 or so minutes as we deep dive in the wonderful world of Kotlin and Compose. I'm truly honored to be presenting in this historic venue and want to give a huge shout out to all the organizers of this conference for doing such a fabulous job. Uh, a round of applause to the organizers because I think I haven't seen these many people in I don't know how long. So I'm very excited to be here, and with that, we can get started. So I work as an engineer at Airbnb on their Android app, and as many of you already know, Airbnb is a global marketplace that connects travelers with hosts that offer unique experiences and accommodations. The community has grown to over 1 million hosts that have welcomed over 1 billion guests across almost every country in the planet. My team is responsible for building and maintaining Airbnb's UI infrastructure, and our goal is to make sure that our front-end engineering is efficient. Today, we'll be focusing on exploring the methods we employed to automate various aspects of our UI infrastructure. And animation on cue, awesome. So to kick things off, we're going to roll back time because I think, given how diverse the Kotlin community is, some background context is very critical. We're going to go back to the summer of 2013 when React was first open sourced. React introduced a novel way of writing UI and revolutionized web development. It demonstrated how impactful declarative programming can be in creating user interfaces. Initially, there was a lot of pushback to the idea, and it, in fact, faced a lot of criticism. This was because it was trying to introduce a new mental model for building UI that didn't immediately click, and a lot of critics felt that it was, in fact, a huge step backwards. But over time, the web ecosystem came around to its idea and started embracing React, and its adoption kept growing. React now powers a significant portion of the websites that we use on a daily basis, and is one of the most development web development frameworks out there. Fast forwarding that to now, and the wave that was started by React has now spread to the other front-end platforms as well. All the top front-end platforms have now converged on the idea of using declarative programming for building UI. These certainly took inspiration from how the web ecosystem evolved, and now both the leading development ecosystems recommend their declarative-first offerings for building apps on their platform. A core principle that all these declarative frameworks share is the idea that your screen is a collection of smaller, modular, reusable pieces of UI, often referred to as components. These components can then be combined and reused in a host of different contexts and combinations to build the screens of our apps. As engineers, we've been trained to know that reusability is a good engineering practice. And these frameworks really make it simple to create reusable components. Since we are at Kotlin Conf, it's only fair that I focus on a framework that uses Kotlin and all its amazing features. The framework that we are going to be focusing on is Jetpack Compose, and it brings declarative programming to Android. A significant number of Android apps already use it for their development. Since we have a very diverse audience at this conference, we will look at how one goes about creating a custom component that renders some text on screen using Jetpack Compose. So we start off by creating a simple Kotlin function that's taking in a string parameter. And then we use a default function called text that's exposed by this library itself. This does exactly what you think it does, which is it's capable of rendering some text on the screen. We've also set some styling information here to fit our use case. Invoking this text function requires you to opt into Compose land. And you can do that by annotating your Kotlin functions with the @composable annotation. Composable functions can only be invoked in other composable functions, which is very similar to how suspend functions work if you've ever used coroutines. And with these few lines of code, we've essentially created a brand new UI component. Now, this is an oversimplified example, but generally speaking, it's a lot easier to create new components with declarative systems, as they typically require less code, and the syntax is fairly intuitive. Now, don't get me wrong, this is absolutely amazing and reduces barriers to entry. Having said that, this shift to declarative programming has brought with it its unique set of challenges. Once you start adopting these frameworks in your code base, you will quickly start noticing a few things. In a short span of time, your code base will end up with hundreds of reusable components that developers across multiple teams in your company are building on a daily basis. For these components to be truly reusable, other developers need to be aware of its existence. Otherwise, how else are they going to reuse all this? So discoverability is a huge problem. I'd actually take it a step further to say that the two core tenets of these systems, which is reusing components and making it easier to create new components, they themselves are at loggerheads with each other. So let's double-click on this discoverability problem for now. This is the first piece of UI infrastructure that we are going to be tackling today. When I'm talking about discoverability, I essentially mean that we need a way to search, visualize, and interact with components that exist in our code base. And I mean all the components that exist in our code base. And we will do this together as a group and figure out a solution that might work for us. And so one solution that a lot of companies have adopted is that they would create some kind of a component browser, which essentially lets you add all the components in your code base to this central debug app almost. So why don't we try to emulate this and create something using the tools that are available to us? Now, we can't start any project without spending an hour deciding what we should call it. And we will obviously also buy a domain name that we will never use. But since we have limited time today, and Hadi does not allow me to do that, I'm going to use my veto powers and give this project a code name. We'll call it Showcase with a K, as it's a showcase of all the components of our code base. And before we start building, let's actually list out some of the requirements to stay focused and so that all of us are on the same page. The first thing that we need is all the components in our code base should end up in this browser. We want some kind of an organization so that it's not a flat list of components. And we should also be able to search through components, assuming that we end up in a world that has 1,000 components in our code base. And last but most importantly, we don't want to do any manual work. This system is supposed to work for us and not the other way around. And the last point I mentioned is absolutely critical. So let's talk about a typical workflow of a developer that's using Compose to build components. Compose does offer a first-class mechanism to preview composable functions that a developer has developed. You do that by creating an explicit preview function, which is nothing but a wrapper around your components with mock data. You then annotate this function with the add preview annotation. And it also lets you add some metadata about this component, so you can add a name or the group that this component might belong to. And by creating this preview, you are able to visualize this component right in Android Studio, which is the IDE that we use for development. Now, this is a really powerful feature and is a first-class feature of the framework itself. Unfortunately, this only works at the file level. And so you can only visualize previews that are currently open in Android Studio. Having said that, if we can somehow figure out a way to leverage this, it would be extremely valuable because this is second nature to what a developer is doing on a daily basis. So let's revise our problem statement. Our goal now for the next few minutes is that we want to collect all functions that are annotated with add preview and show them in this component browser that we aspire to build. Thankfully, Kotlin offers a really effective tool for doing this, and that tool is called Kotlin Symbol Processing, or KSP as we lovingly call it. It basically lets you process annotations in your code base in an opinionated and efficient manner, and efficient being the keyword here. Whenever you're using KSP, there's a very high likelihood that you will also be generating some code, which is what we'd probably need to do as well. And so for some background information here, from the perspective of KSP, every Kotlin file is simply a collection of Kotlin symbols. The names of what each symbol on this screen isn't important, so don't pay attention to this wall of text. All you need to remember from this slide is that Kotlin file is a collection of different types of symbols, depending on the role that they're playing in that file. And we also get a lot of information about each of them through KSP and the abstractions that it has itself. Anytime you decide to use KSP, it's very important that you figure out the end state first and try working backwards from that. And so if we look at what we're trying to build again, we can sort of build this experience if we had the name of the component, the group that this component belongs to, and most importantly, a reference to the actual preview function, which can just be a lambda that we can hold in memory. And this data class is essentially capturing these three pieces of data that we need to create this browser. And we will heavily use this later on in the presentation. We'll also define an interface called Showcase Provider. And every time you see the keyword Showcase, it's only because that's what the code name of this project is, so I'm just prefixing it. It has a function that returns a flat list of these Showcase browser component instances. Now, there's a very specific reason why I've created this interface, and we'll realize its value later on in the presentation. Finally, we will aim to create a class that essentially implements this interface, and that will help us create the browser that we want. Now, when you look at this pseudocode, there are a few problems that come up instantly. Most apps these days are fairly modularized. And so our components could have been declared in any of the tens or hundreds of modules in our code base. So wherever we decide to generate this final aggregated class, it needs to be in a module that has access to all the other modules in our code base. Otherwise, the generated class will have build errors as it will not be able to resolve all the preview functions. In order to solve this, we are going to declare a new annotation. We're calling it Showcase root. What this does is that it allows the end user of this infrastructure to declare a class in the root module of their app, so whatever is the main module that has all the other dependencies. And they will annotate their class with this annotation. And this is the only setup code they need for us to understand which module should be treated as the root of your app. The second problem is slightly more gnarly, which is how do we take into account the root module aggregating all the other previews in our code base. And this problem is due to some intentional and practical design decisions that KSP took. Now, this might not be obvious, so let's look at an example. Imagine your project is a collection of interconnected modules, like pieces of a puzzle. KSP operates on a per module basis and will process each module in isolation at a time. As it processes the module, it will analyze the files and symbols within that specific piece of the puzzle. This focused approach allows KSP to work efficiently, even in large projects. And so just running through an example, as module 1 is being processed, KSP will have access to only module 1 files. And the process continues for every module that it goes through. And in this example, module 5 is our root module. And so by the time you reach the root module, module 5 has no way of accessing the previews from the previous modules that have already been processed. Now that's a problem. One way to overcome this limitation is to leverage the idea of a centralized package location. And what I mean by that is that each module, as each module is being processed, we will generate a file that has metadata about all the previews in that specific module. These files are then stored in a fixed package location. In this example, the package name happens to be com.airbnb.android.showcase, but it can honestly be anything that you want as long as it's a fixed location. And so running through an example again, when module 1 is being processed, we dump all the metadata in this fixed package location, which basically means that whatever classes I'm generating, it should have the package name as this fixed package location. And we repeat the same process for all the different modules. And one thing worth calling out is that when you actually look at the build folder wherever I'm generating the file, each file is being generated in the respective modules. And so when you look in the file system, it's actually in a different location. But because we've added them to the same package, we are able to use some KSP APIs to still access them at a single go. And so finally, when the root module is being processed, which is module 5, one of the steps that we need to do is to peek into this fixed package location, collect all the metadata, and then write the final aggregated file that we need. Now, all of this, I understand, sounds very vague and abstract. So why don't we spend the rest of the presentation actually trying to implement this, and then see how we can extend this further for other use cases. The entry point to KSP is an implementation of a symbol processor. In this case, it's something that we are calling Showcase processor. All the logic that really goes into this will be in the overridden process method. Anytime you think about writing any sort of an annotation processor, there are 4 steps that you are most likely going to follow. Step 1 is finding all the symbols that have the annotation that you care about. We're going to leverage the resolver, which is part of the KSP infrastructure itself, and it gives us access to compiler information like the symbols, which is what we are interested in. Since we're trying to find all the functions that are annotated with @preview, we're going to leverage the getSymbols with annotation API that allows us to pass the fully qualified name of the annotation that we care about. And this will return a list of all the symbols that have this annotation. And then we'll iterate through each of them. Now, as a reminder, the function variable that you see in that lambda is essentially a Kotlin symbol representation of the function that you see on the right. But this function won't always be declared as a top-level function. It's possible that someone might store their previews inside an object, or maybe inside a class. We will have to take this into account as well and store the relevant information so that when we need to invoke the preview function again from the browser, we are able to successfully invoke it. All right, so let's start parsing all the information that we need. And so we first look at the presence of the preview annotation among the list of annotations that a function might have. As you remember, this function also has the add composable annotation. So we want to make sure that we just get hold of the correct annotation for parsing. Once I have the right annotation, I'm going to parse information from the arguments. And so we care about the name and the group. And it's very easy to get that information. And finally, we check if the function is wrapped by a symbol that's a class declaration. And if it is, then we will take more information that we would need. And so the two things that I'm taking here are the simple name and the class kind. And the simple name is very obvious, like it's just the name of the class that my preview might be wrapped with. And the class kind tells us whether it's a class or an object. And this is really all the information that we need in order to successfully be able to invoke the preview. Now we will store this in a data class that I've conveniently called metadata. And if naming is hard, this presentation is a very clear example of that, given all the names I've used so far. For good measure, I'm also storing the function symbol itself so that I have access to more information in the future, like the package name of the function or anything else that might come up for a future use case. Now, reusing add preview annotation is really useful from the perspective of this just works out of the box, but it's also limiting. What if we want to add more metadata later on that the add preview annotation cannot support because it's part of the Compose framework itself? So we'll go ahead and create a new annotation purely for future proofing's sake. It currently supports the exact same properties that we are using the add preview for, but maybe in the future it might diverge and the future might come 15 minutes from now. Now, in theory, one could annotate their preview functions with both add preview and add showcase composable. In such a scenario, we always want to prioritize add showcase composable because that's a more opt-in mechanism from the perspective of this browser. So we'll parse this new annotation in the exact same way that we've parsed the preview annotation. I've basically refactored my code that now takes in the full qualified name of the annotation. And let's assume that that is now available as a utility function. And so what we have now is a list of all my preview functions and all my showcase composable functions, or metadata about those functions. And so we need to consolidate this list because it's possible that there are duplicates in case they were annotated with both the annotations. And we'll use a combination of the package name, the wrapper class, if any, or it could just be null if it wasn't wrapped inside anything, and the name of the function itself as the first level of deduping mechanism. And then we do another level of deduping to ensure that no two components have the same component name or the group name. If you wanted, you can also spit out some information as part of the processor itself so that we let the end user know that they have duplicates. All right, so we have two annotations down that we care about, and we have the final annotation, which is the root annotation we discussed a few minutes ago. We use the same API, which is get symbols with annotation, and check if the current module that is being processed has the presence of the showcase root annotation. If it's null, it means that we are not in the root module and we are processing a different module. But if we do find it, we know that we are processing the root module. And we don't need to parse any other information. We just need to know if this is null or not. And that's enough information for us to proceed. And so going back to our process method, we also have the root module, which could be a nullable value here. And now we've collected and parsed all annotations that we need. The next step is the validation step, which is also very critical when you think about this from an API perspective. Here, we want to make sure that we don't allow the users to misuse this infrastructure. Additionally, we also want to give them as much information as possible so that they can fix the issues if there's something wrong with the setup. And this is fairly straightforward, so I'll just give some examples of what some validations could look like. Because we are trying to aggregate preview functions in a central location, we need to make sure that the preview functions are accessible, and so they cannot be private. Or preview functions cannot have non-default parameters, because we would not know how to initialize the function otherwise, or invoke that function otherwise. As long as it has default parameters, we can simply leverage the default parameters and still invoke that function. And the third validation that we would probably want to add is that you can use add showcase composable only for add composable functions. This is, again, very straightforward, so I'm not diving too deep into this. We have all the metadata available as part of KSP, so anyone should be able to figure out how to add those validations. It's just a bunch of if-elses in reality. All right, so the next part is the more interesting part, which is where we actually are going to generate the code. And there's a default choice for generating Kotlin files, and it's a library by Square called Kotlin Poet. It's really a standard in at least the Android community, and all of us use it whenever we want to generate code. It does provide a really simple API, and that's basically what we're going to use. As a reminder, we have this consolidated list of all the metadata objects for previews. And this metadata, again, is only for the module that's currently being processed. So it still does not have information about anything else, just the module that's currently being processed by KSP. And I always miss this animation. And for every metadata element in this list, we are going to generate two files. The first file that we're going to generate is a top-level property in the same package that the original function is declared. And this is essentially what this package looks like. If you remember, we declared a data class at the start of the presentation with the three things we care about. This property is essentially an instance of this data class itself, where we are storing the name of the component, the group of the component, and the composable function itself. For generating the name of this property, we are basically using a combination of the package name, the group, and the name of this preview function. And we are doing this to make sure that these properties are unique. And we've already done some deduping, so we have a high level of confidence that this would be unique. This is also where we need to take into account how we can invoke these preview functions. And so if this preview was actually declared inside an object, we will have to make sure that this generated file takes that into account, or even a class for that matter. The next file that we're going to generate is the file that we said we will put in that fixed location. And this is essentially what it looks like. This is pretty straightforward. So let's look at some of the interesting elements of this file. The first thing you'll notice is that it's in that fixed package location that we spoke about earlier. The name of the file is basically the same as the name of the property itself. I've just added a prefix, and that's it. Honestly, it can be whatever you like as long as it's unique. And what I'm doing now is I'm annotating this class with an internal annotation. I'm calling it Showcase Code Gen Metadata. Again, name not important. But I'm using this to store the two things that I really need to uniquely reference that property. And all I need is the package where that property was inserted and the name of that property. And with that, I can uniquely reference every single property that we previously saw. And this is essentially what it looks like in that fixed package location. All right, so going back to the root module that we were holding in memory, whenever we detect that showcase root annotation is found, it's an indication that we are currently processing the root module. And the main thing we want to do here is write that aggregated file that has information about all the previews in our code base. All right, so the first thing that we will do here is getting all the symbols from that fixed package location, which is essentially a repository of metadata for all other modules that have been processed so far. Then we filter out only symbols that are class declarations, because we know that we care about only the classes that we generate. And then we iterate through each of these class declarations, and then just focus on classes that have been annotated by this internal annotation I just mentioned, which is Showcase Code Gen Metadata. And if that's available, that means we've found the metadata class that we need. And then we're going to peek into that annotation and essentially parse those two fields, which is the package name of the property and the property name itself. There are two additional fields that were needed for incremental compilation. We won't be covering that today, so ignore the last two fields there. And we just convert this to a list, make sure that we filter out any non-null instances, which basically will only happen if we encounter a class which did not have this annotation. All right, so now we have the metadata from all the other modules. But this won't have metadata from the root module itself, because we won't have that available at the time of peeking into this package name. And so what we'll do is we'll use the current metadata from the previews and then combine it, convert it to the same data class object essentially. And now we have the aggregated list of all the previews in our code base. The next step is easy, which is writing the aggregated file that we started with. And this is what it basically looks like. Again, we'll be using Kotlin Poet for writing this file. The actual writing of the file is not that interesting. Figuring out how to get this aggregated metadata was the interesting part. And so that's where we'll stop as far as diving deeper into these concepts. And as a reminder, like the list is just a list of those properties that we wrote. And so if you look at what that looks like, it just has the group name, the group name, the name of the component, and the composable function itself. All right, so now we've successfully created that aggregated class that we needed. And we have all the metadata for previews in our code base. But we don't stop there. We'll actually write a second file, which is going to be a browser intent, which is nothing but an Android intent to open up the component browser. Now, this is a nice-to-have feature because we want to make sure that from the perspective of an API, we want to make it as simple as possible for someone to reach that component browser with all their components. And so we've created an object called Showcase. It's an empty object. But anytime we're trying to create any utility functions, we generate them as extension functions on this object. And so in this example, I'm creating a function called getBrowserIntent that takes in a context, and it returns the intent back. I initialize the intent, and the activity that I want to start is the Showcase browser activity. Now, we've not looked at what the Showcase browser activity is, and we'll take a look at it shortly. But it requires some information to be able to pick up this aggregated file. And so we use the intent extras to basically pass it the fully qualified path to this class that we just generated. And it just returns the intent. So now the intent is available for the end user. And if you look at the usage side of it, all the end user has to do is start the activity, use this get browser intent function, pass the context, and we automatically are able to open up a component browser. And imagine adding this as a button in your debug menu, and you just tap that button using this intent, and it shows up your component browser. Now, the final piece of the puzzle is actually using the generated code. And we briefly touched on the Showcase browser activity. So let's look at what its implementation looks like. The first thing we'll do is we'll parse the information that we just piped into the intent extras. And because this is set by the generated code itself, the user did not have to worry about this because our intent took care of taking care of it for the user. So what we are really trying to ensure is focusing on keeping the API as simple as possible. The next thing we'll use is use reflection, which is a big no-no for some reason, but when you're dealing with infrastructure stuff, it's completely okay to do stuff like this because we are only using it once in the entire existence of this browser. So please don't frown. I saw some people showing me eyes, and I truly apologize for that if you don't like this. So we'll use reflection to essentially create a new instance of this class because we have the fully qualified name of this class available inside that class key object. And then we use new instance. And now we have that class that we just created. And because this class implements the interface that we started with at the start of the presentation, we can actually typecast it to that interface. This was the primary benefit of creating an interface upfront because now we have a cleaner way of accessing things inside this class, which had this function called component list. At this point, we have everything that we need to be able to create that browser experience. From this point onwards, this is just a regular app that anyone sitting here can implement. It's not that interesting to really cover because there's no magic happening from this point onwards because once you have the metadata, you can very easily create this browser that has a list of all the groups of components. When you tap into it, you then see the components in these groups. And obviously, the detail screen for that component itself. Now, we've made a lot of progress in maybe the last 30 or so minutes, but we don't want to stop here because we've just unlocked some superpowers going forward. And we decided to take this a step further where we were already able to preview our components. It's just as easy to showcase these components in a host of different contexts because Compose makes it easy to force your component in dark mode or RTL layout or changing the font size or the density scaling. And that would be an obvious addition because now you don't have to manually see these variations and permutations. The Showcase browser itself is just generating them for you. So when you open the detail page, you have all the variants that your components can be in, and specifically the variants that you might care about. The next problem that we noticed was that Jetpack Compose did not have the concept of styles of a component. Over time, we noticed that once we created a component, other teams would often come and create style variants. And we had this desire to be able to link all these components together. Now, one way of doing this could be maybe you declare all the style variants in the same file that the original component was declared. And that's completely okay, but it's not very scalable. It also forces the team that implemented the original component to take ownership of these style variants, and we don't want to do that. And so let's attempt to add support for this with the existing pipeline that we have so far. If you remember, we had created Showcase Composable, the additional annotation. Now this is going to come in handy. What I'll essentially do is we'll add two fields to it. The first field is called the style name, and the second field is the default style in case we want a preview to represent the default style of a component. And here's what the usage of this would look like. In this example, I'm representing the default style of a button, and then I'm creating two more styles, and I'm using the style name property to give a name to these styles for the same component. And whatever we've done so far, we'll just propagate these two extra fields everywhere we pass name and group before this. Again, this is very straightforward. We are pattern matching at this point because our pipeline is working end-to-end. So we are just adding two fields everywhere we've generated files so far. And what we end up with is an experience like this in the browser, where we can essentially link all the styles of a given component on a single screen. And again, this is slightly hand-wavy, I understand, but it's honestly very straightforward once you have all the metadata. We now have a reliable infrastructure to support components and have also solved the discoverability problem to some level. But why just stop at that? There were some other UI elements in our code base, like colors and typography, that should also be documented in the browser. To do that, we created two new annotations. In this case, Showcase Typography and Showcase Color. The names are honestly identical. You could have very easily used the previous annotation. But for future-proofing sake, assuming that we want to keep adding more and more features and make this more useful, we decided to diverge early on. On the usage side, you use it very similar to how you use preview functions. The only difference is that you're annotating fields with this annotation. And then we add logic to parse these two new annotations that we've created. So you'll remember these two functions. At the same spot, after I parse the previews, I'll also parse my colors and typography. The logic looks very similar. The interface had one method. Now it will have a couple more. Again, I'm skipping a lot of details because everything that we've seen today is what basically needs to be updated. And it will start feeling repetitive. And that's not a bad thing. We want to make our incremental changes easy. And that's what this has enabled us. Because we now have the right base to keep adding features. And finally, we'll make changes to our Showcase browser activity, where we now have created an additional screen at the beginning that basically has components, colors, and typography. And then based on the metadata, we show and render the previews based on the type of element. And with this, we've successfully implemented our component browser with some additional features that we did not even aspire to do at the beginning of this presentation. All right, so I think we have a good handle on the discoverability problem, and have solved it in meaningful ways. So let's quickly shift our attention to the quality aspect of UI infrastructure. We currently have this interface that has a list of components, colors, and typography elements. And we're going to add another method as part of this interface itself. that simply combines these metadata lists into a single data class. We are then going to generate an extension function on the Showcase object. And what we are doing here is exactly what we just saw. This logic for using reflection and then creating a new instance of that class is what the Showcase browser activity was doing. But why limited to just the Showcase browser activity? Having the metadata is just as useful as having that component browser. And so now we've essentially created an API that allows anyone that's using this infrastructure to have all the metadata about all the previews of components, all the colors, and all the typography available. So even if you don't want to use the browser, that's completely okay. Because now you have this rich information with a single line of code, which is extremely powerful because you can do some amazing things with it. And so the way we ended up using this is specifically for screenshot testing. And we had this desire to screenshot test every single preview in our code base. Doing this is actually very trivial because we already know what needs to be tested, and we also have access to everything that needs to be tested. And so there's a really popular library these days called Paparazzi by Cash App, and it's super popular for screenshot testing, primarily because it's able to do this screenshot testing without requiring a physical device. And so your tests are more deterministic and also faster to execute. Plus, you save some money because you don't need an emulator anymore. And so what we did using this was, and again, I apologize for being slightly hand-wavy here, but given the amount of time we had, I'll briefly glance over essentially the file that we generate now for our screenshot testing infrastructure. So it's essentially a parameterized test that's using the test parameter injector as the runner, which is a library by Google. And it creates a test matrix on a number of factors that are customizable in basically 3 lines of code. So you can decide if you want your screenshots to just be taken in left to right context of both left to right or RTL, or if you'd like your screenshots to also be taken in dark mode. Very easy to configure this based on some setup code. And the test itself generates the API that we just saw, which is the showcase.getMetadata API. And then we create a flat list of all the elements that we want to test. And the parameterized test basically takes care of iterating through each and every element and taking a screenshot of it. And that's it. Now you might ask me, you've shown me a lot of code, and that's too much for me to understand. Wouldn't it be amazing if you didn't have to write all this, right? And so thankfully, we've open sourced it. It's available for you to access it. By the way, it's been around for 3 years, so it's not new. I'm not announcing anything. I'm just speaking about this now. Of course, I missed the animation. I've honestly barely scratched the surface because I had to condense all this information in 40 minutes. Showcase takes care of a lot of other features and nuances that I had to take care of because there's so much going on with previews in general and compose in general. And what you get is not just the component browser that has colors, typography, and other additional features like support for preview parameters as an example, or parsing your KDocs and showing it in the browser itself. But some other features as well, including the paparazzi screenshot test example I showed you. It's available as a separate artifact. So if you're already using Showcase, with 3 additional lines of code, you get an auto-generated paparazzi test, which we've been using in production, and it's been working fine for us so far. All right, so to summarize, I honestly started this project only to learn annotation processing. That was my only goal with this project because I know annotation processing or code generation or meta programming, however you see it, is a really valuable tool to have in your arsenal as an engineer. And I would encourage you to spend time on it. Keeping composability in mind was also something that we ended up benefiting from. As you saw, every aspect of our infrastructure is using something that we already were doing. And so it helped us iterate very fast and move quickly, which is very valuable in today's times. And don't reinvent the wheel. Please just use Showcase. I've given you all the code, I know, but don't waste time on writing this yourself. And if there are any features We would love some contributors. I've already been engaging with some amazing people that have been contributing to Showcase, and if that is daunting, I'd be happy to hold your hand and get you involved in this project. So please feel free to reach out. And with that, my presentation ends. I don't know about you, but I'm certainly exhausted, and I need a nap. So thank you for joining me. I really appreciate it. I did not think I would have any time remaining, but we have 5 minutes, so why don't we take some questions?
Oops. Sorry. You want to first?
Yeah, thanks. My question is, does this work for Compose for Desktop as well?
It does not, but it would be an amazing contribution.
I was afraid you'd say that. No. Probably more realistic. What about arguments to the composable functions you're previewing? Does it?
Yeah, so ideally the preview functions itself take care of passing that mock data, because that's the whole point of preview functions. Like, we pass in mock data so that the preview functions don't have to deal with it. There are preview parameters. Yes. Yeah, and that's part of Compose itself. That's what we do. There is one nuance, which is Compose does support preview parameters, and Showcase also supports it. I just did not cover it in the presentation because it just complicates the description. Hey.
Thank you for the great talk. So when we're writing our composables and previewing them, generally our previews are showing us, like what we're building and that kind of stuff. Whereas tests, specifically on the test side, we want to, hit, all of the possible edge cases, all of that. So do you find that your previews are becoming maybe more bloated to handle edge cases, or are you also writing, in addition to those basic, preview automated screenshot tests, are you also writing other tests for it, or how do you find that balance?
Yeah, so I think we've certainly seen that we have a lot of previews, and part of the motivation to move to Paparazzi is because it's more sustainable in case we have an explosion of previews. We are also trying to limit the amount of screenshot tests we do, so being smart about choosing which modules have changes and only limiting those modules from the perspective of making sure our CI times are reasonable. In terms of interactions, we have a separate set of tests that actually go through every screen, and that does not happen at the component level. That happens at the screen level, which is slightly different because we have an opinionated way of having some state for a class. And because we have that state being passed to every screen, not class, I meant screen. And because we have that opinionated way of passing that state to that screen, we can easily write snapshot tests. And we've also written some code, or at least my colleagues have written some code, to go through every composable and then find the ones that are interactive, click them, record the JSON changes, and essentially see the diffs on every PR. And so these are the two set of tests that we're using specifically for Compose.
Yeah, I see that we have more questions, but I think we ran out of time, so probably you can just ask in the break, yeah? Thank you so much.
Thank you, folks, for joining.